Alright, so we've gone through the basics of audio, but I thought it might be interesting to expand upon that a little bit and take a look at 3D positional sound. So this is something you may want to incorporate in your games, but in order to really take advantage of it, you have to have either stereo speakers or preferably a surround sound type system where you have multiple speakers corresponding to allowing sounds to actually move around the soundscape. Now this is actually a 3D technique, so we're working in a 2D game world. We're going to kind of play with that a little bit. Basically, by treating our 3D world as a 2D world, we're going to do everything in the XY plane. So all of our Z values and our vector 3s are going to be 0. And what I was going to do is just take the audio example game that we built previously and add just a sound to each coin. So as you get closer to the coins, you'll hear kind of a bleeping of some kind. And the sound I think I'm going to try is this one. So I'm going to go ahead and export that one. And save that in my downloads. And then I'll open my content manager with the editor. And pull that sound in. That is in my downloads. And that was Power Up 3 Wave. And I will go ahead and copy that file, save this project, and now it should be in there and it should be built and compiled. Now in order to use 3D positional sound, we need two things. We need an audio emitter and an audio listener. And these represent where the ear or the user is in the scene, the player, and then what's actually creating the sound. So I'm going to start by adding our listener directly to our slime ghost sprite, which represents our player. And to do that, I need to bring in the audio namespace, which is where those audio listeners are defined. And I'm going to go ahead and declare an audio listener in here as a property. Public audio listener. Get, and actually I'm just going to make it have a getter, and I will initialize it to a default of a new audio listener. And that's not being picked up, so actually framework.audio, have to have the audio namespace. There we go. So now we're picking that up. We're going to go ahead and just comment this. Okay, so that should add our listener, and if we jump to our coin sprite, this is where we're going to add the audio emitter. And in this case, I'm going to leave this as a private variable. And again, we need Microsoft.xna.framework.audio to get that up and running. And I'll go ahead and set it to a new audio emitter by default. Okay, now when I construct this coin sprite, I need to set up the emitter values. And the emitter has 3 values that we need to worry about. First is the position, or where it is in the world, which actually is pretty straightforward because our coin doesn't move around at the world. Its position is always going to be the position we passed in. However, this is a vector 2 and this is a vector 3. So, oops, this .emitter position is a vector 3. So we need to supply a vector 3 as our argument. So we're going to actually construct a new vector 3, and one of the overloads or overrides for this constructor is we can actually pass in a 2-element vector and then a value for our z coordinate. And since we want everything to be in the xy plane, we'll just go ahead and use a 0 for that. So that will create our emitter, position it, and then we have to define what the up direction is for that emitter. And we'll just set that to be vector3.unitz, so a unit vector in the z direction, which is technically if we're doing 3D rendering out of the scene, out of the screen, but we're basically pretending this world is, yeah, so out of the screen would be up for this ghost, and y is going to be going that direction for y, and then x is going to be this direction. So this should work for us. And then we need a this dot emitter dot forward, so the direction that's forward for this emitter. And to start off with, I'm going to set that to vector 3.unit y, so it's kind of I guess an upward direction. However, what we really want is this is the direction that's emitting sound, and we want these coins to seem to emit their sound in every direction, so be omnidirectional. So to do that, there's actually a little trick we can play. We can actually always point this emitter at the player. So wherever the player happens to be in the game world, we're going to point it straight at him. And to do that, we need to actually add an update method, which of course we didn't have in this game. Public void update for the coin. And we'll go ahead and do a game time, and then we'll do a, well, let's actually give it an audio listener that it's going to be listening to, because we're also going to need that. So and we can get the position from that listener. So to update that forward vector, we can say emitter.forward, and we can take the emitter position and the listener position, and we can do vector subtraction on those. So our listener is coming in listener.position, if I got the name right, minus emitter.position, and that's a vector 2. So we need to go ahead and throw this again in a vector 3 constructor. And provide that second argument for the z value. So now this should give us a vector that's always pointing towards the player. Then if we go to our slime ghost, we have our listener. We need to set its initial values as well, and we don't actually have a constructor for our slime ghost. So let's add one, because we really only need to do this initialization step once for most of the audio listener. So the audio listener dot up vector, for example, is always going to be, in this particular game, vector 3 dot unit z. And usually it's going to be an up vector, so up in the y direction if we're doing a 3D game. But it just kind of depends on the game that you're doing. And if your player happens to maybe lie down in a bunk, then obviously it's going to be out of their head in the direction that their head's facing. So you do have to tweak it potentially in some games. For this, we really don't. The position, we can go ahead and set to be equal to a new vector 3, and then our static position plus the 0 on the z, and forward again, I'm just going to use vector 3 dot unit y for right now, and then when we come down to the update, we're going to update this. So basically, we want the position, after we've moved this sprite around, we want to update the position. Which would be audio listener dot position equals new vector 3, our private position variable, and a 0 to put us in the XY plane. Now we also need to update that facing vector, so the direction that we're looking at. And that gets a little more interesting, because basically we're not storing that variable anywhere, that value. Let's go ahead and just add a vector 2 here, and we'll call this facing. And then we're going to go ahead and set the facing to be gamepad state dot thumbsticks dot left. So we're basically using the same value that we have here, and that's the direction that we're pointing us in. And I'm not going to invert the y-axis, because actually our y-axis is already inverted. in this 2D screen coordinates versus the 3D coordinate system that we're using for our sound. But we really don't have to worry about that. As long as we're consistent, it should just work. Okay, and these position updates, I'm going to go ahead and wrap those. Even though there were one-liners before, we're going to have to change those because this gets the facing based on the thumbsticks. But if we're using the keyboard, obviously we're going to get a slightly different facing. So we're going to say facing equals, and we're going to actually just use exactly the same vectors we did here, only like I said, we're going to invert those axes. And then here, because the x and axis is not inverted, we'll just go ahead and use exactly what that new vector was. And you might realize there's a slight opportunity for optimization because we're actually setting this vector. We could actually just use it there instead of restating it, reconstructing the struct with the same values, but I'm not going to change it right now. Okay, so update the position and facing of audio listener. Now there's a little challenge here. This facing vector, if we haven't hit any keys, is going to be exactly what we got out of the thumbsticks. And if we haven't moved the sprite, this value is actually going to be a vector 2 of 0, 0, saying that we're not moving anywhere. So we want to make sure that we only update the facing when we're moving. So when we stop moving, we want to keep facing the direction we were facing before. So we're going to do an if check, and we're going to check that position vector and see if it's equal to vector 2.0, so the 0 vector. And if this is the case, if the x, y, and by the way, the equality operator is overridden for the struct, so it's actually looking at the values. It's looking at is the x and the y both matching? Are they both the 0 values? If that's the case, we're not going to move. Otherwise, we will go ahead and set a new vector 3 with facing and 0. Alright, so that should make sure that we're always turned in the direction that we've been moving the last. So that updates our Slime Ghost sprite. And now in our game, we need to update our coins as part of this update loop, because before our coin didn't have an update, we weren't doing anything physics with it, so we didn't need to worry about it. Now we do, and we could go ahead and create another for each and iterate through all the coins and invoke its update. There's nothing wrong. Well, that would certainly work. The problem is now we're actually going through the loop twice of iterating through the same objects. There's really no reason to do that. It makes a lot more sense just to put it inside of this loop so we only iterate over them once and we do all the things we need to worry about. So in here we're going to do coin update, and we're going to pass in the game time, and then the audio listener we're going to pull out of that slime ghost dot audio listener, and that's why we made that public, is that way we can pull out and pass it in here, and that's going to update our coin. So that updates the emitter and the listener, so we have all of those in the positions we need them in. Now we want to take the sound that we added, this power up 3, and actually play that, and I'm going to do that from within this coin sprite. So after when we load our content, we're also going to have to load a an sound effect. Content.load sound effect, and this is going to be that power up 3, and again no extension. Now I just use a local variable here because we actually don't need to hold on to this sound effect after we've constructed it. What we actually need is a sound effect instance. And a sound effect instance is an instance of a sound effect. And when we hit play on a sound effect, it actually creates an instance for us, which is basically the streaming buffer that gets sent to and works into the sound card. But we can also manually construct one with the create instance. And the reason we have to do this is we want to actually change the 3D positional values, which are part of the instance itself, not the original sound effect. So fxs instance equals this. That constructs our instance. And now on our update, we're going to take that instance, sfx instance, and call apply 3D. And we have to do this every frame, because every frame our objects have moved around the scene, or at least our ghost has. But also our emitter has changed its facing to face at that ghost. So we're always looking at the ghost. So we're going to put in our listener and our emitter, and make sure that those are updated. And then we're also going to come in here and SFX instance dot is looped. So we're going to make this continue to play over and over and over again. So if you want a looping sound effect, you have to create an instance. That's the only way you get it. And then we also want to tell it to play. SFX instance dot play. Okay. So now if we were to run the game, and audio lister and coin sprite line 76. Not line 67. Audio center. There we go. And vector 3, vector 2, coin sprite line 69. Oh, these are already vector 3s, so we don't need to construct it into a vector 3. There we go. So it's a little hard to tell with the music, because the music is a bit on the loud side. So I'm just going to stop the music for the moment, so that we can feel or get the sense for that sound effect. So as we get closer, notice it gets louder. And if you're in stereo, you'll notice that it's actually flipping which speaker it's playing on based on the side of the coin we're at. Now notice too that when we get close to where that coin was, we're still hearing that sound. And that's because well, we've actually not stopped playing the sound when that coin is collected. So we could expose another method, do a lot of extra work, but if we go back and look at our slime ghost sprite, notice that when we set this up, we actually said collected, or not slime ghost, coin sprite. We said collected was a property, so we have a getter and a setter. We can actually provide bodies for that, so let's create a private backing variable. We'll set that to be the default to false. And now we can define the bodies for our getter and our setter. And the getter is a pretty simple body. We just return our private backing variable. But the setter, we're going to do a little bit of logic. So we're going to go ahead and set the collected equal to the value, which is what it was doing before. And then we're going to check to see if it was collected. And if it is, we're going to say sfx instance dot stop. So as soon as this collected gets set to false, we'll stop playing the sound. Now if we changed it back, it's still not going to play, but for our particular game, that makes perfect sense. We only initialize and run these at the start of the game. If we wanted to change that, then we'd add an else branch and start the sound effect again, which would work just fine. So now, if we go get near this coin, it's pretty loud on the speaker. We collect, and then you can't hear it anymore. We just hear the more distant ones. And as we get closer, we hear those ones as well. And then as we collect them, that sound falls off. So there we have 3D positional sound in a 2D game. And you can definitely do this in any kind of 2D game, and of course you can do it in a 3D game.